Now we will start this third lecture or the final lecture of today's webinar. And now we have with us Dr. 𝐀𝐿 from IRI New Delhi. And the topic of his discussion or this speech is application of robotics in agriculture. So I'll go for short biodata of Dr. 𝐀𝐿. Dr. Kushwaha graduated in agricultural engineering from Allahabad Agricultural Institute, Allahabad in 1997 and M.Tech in Farm Machinery and Power from G.B. Pant University of Agriculture and Technology, Pantnagar in the year 1999. He obtained his doctorate in agricultural engineering in the year 2003 from IRI New Delhi. He joined Indian Council of Agricultural Research in 2002 at Central Arid Zone Research Institute, Jodhpur, and later on served as Central Institute of Agricultural Engineering, Bhopal. Presently, he is working at Indian Agricultural Research Institute, New Delhi since 2013. He is associated with postgraduate, master and doctoral teaching and guide. He visited USA, University of Missouri, Columbia as a fellow under Indo-US Norman E. Burlak International Agricultural Science and Technology Fellow Program. He is also recipient of Aryabhatta Shamman from Vigyan Bharati Team Award and Distinguished Service Certificate by Indian Society of Agricultural Engineering, New Delhi. He is fellow of Institution of Engineers, India. He has published about 27 research papers in international national journals and presented 56 research papers in conferences and 7 book chapters / manual, 16 popular articles and 5 bulletins. Now he is actively engaged in development of robotic precision planter, application of electronic and automation in agricultural farm machines, equipments, tools, and studies on drone-assisted spraying system. Now I welcome Dr. Kushwaha and I will hand over the session to Dr. Kushwaha for your speech.
Okay, thank you. Thank you for nice introduction, and I also thank Suresh for excellent presentation by Pradeep Rajan. And he has presented well, and he has given some scope to me to follow up that program. He has worked on precision, and now I am going for robotics. So this is a completely. I also thanks webinar organizer. So nicely they have selected the topics and the presenters, their expertise field. Okay, now I am going to my slideshow. Okay. Now it is in presentation mode?
Yeah.
Okay.
Okay.
Good afternoon.
Good afternoon, sir. It is visible and audible. Okay, sir. You can.
Okay. Thank you. Thank you. First of all, I invite a new system of agriculture robotics. You know that nowadays everybody we have a car and other things. You know that how is it possible? Due to application of robotics in industry, it cannot be possible if manual production system. They successful because they have applied new technology and concept in their production system. Can we follow that one? If we use the robotics and mechatronics, electronics in agriculture, then it's possible that we can do it. Since last 5-6 years, I am working in this direction. As per field of agriculture engineering, we know the each and every subject related to engineering, but always we had some fear with electronics. So nowadays, its fear is reduced now. People are working hard to learn the new skill of electronics, mechatronics in agriculture. So today topic robotics application in agriculture. I have here that different introduction parts, little bit some definition, but I will skip, and some robotics are linking with the industrial as well as other robotics, so that it excites you a little bit that how you can use the robotics in agriculture and the challenges in agriculture robotics. In initial stage, if you say that, if you go further saying that you can apply the robots in agriculture, it is not now, but it can be possible in coming future. And research robotics in worldwide and current status of robotics and what we are doing in India. Okay, we are going to. If you see that timeline, we are working with the human, manual cutting, sewing, other things. Then after we engage horses or bullocks and other power, and we increase our capacity of the cultivation. Then after comes tractor. Even after animal to tractor, little bit resistance is there, that people are saying if tractors come and where our animals are going. Then after, if you see that some advanced tractor, it cab and other things with some autonomous tractor now people are going to introduce, and next future is the robotics. So we are here about to autonomous and little bit with the robotics. Okay, I'm not going to the definition, but nowadays humanoid robotics and some others are going on. Beyond Mitra, these are Indian robots, so I tried that India has also, and but most popular is the Sophia. Even radio jockey robots is also there. So just it is for inspiring that we can also use in robotics. Like in robotics, ideal task in dangerous situation like space exploration, chemical and other things. But where ideal task for us, chemical application in agriculture. If you go for the chemical application with the robotics, it will be always benefit for the human, so that they cannot expose you the chemical. Sometimes monotonous job like weeding, harvesting, extra. That will be required for the agriculture purpose. But for that one is the for the industrial, they are using welding, part picking and manufacturing. That is a monotonous type, that pick and place they are doing. And sometimes high precision are required. Like electronic testing, surgery, now the medical also using the robotics surgery system. Now we can use as a precision farming. So these are the ideal tasks where we can work. If you see that the different type of robotics, that is pick and place, that is move between point to point, and continuous was another one. Sensory, that means they sense and at per feedback they are working. So these are different robotics and very popular. KUKA is a very popular robot and many others. But if you are just planning for any robots, like agriculture engineer, we are thinking about the research. Then which concept we can take? Like if you see the principle, that is Gaussian, cylindrical, spiral, scala, and articulated robot. Different type of their kinematics and their work pace. And out of them, we understand that the Gaussian coordinate robotics is the simplest one, and where the control system it can be very easy. And their performance yield is working volume. That how much volume, how much they can work, and speed and accuracy with accuracy. That is also main parameters. And its resolution, for the resolution of the surgery system or electronic component handling, that is very accurate. But in resolution process, if we go for the agriculture purpose, that means we can take at the precision of 1 mm or 1 centimeter, it can be possible, and that is not a very big challenge or big issue as a precision we are taking. And then how you can perform its accuracy? That is accuracy as per the design program, and repeatability. That means after 1,000 times, 100 times, can it possible to do same with the precision, repeatability. So these are the yardsticks where performance we can check that one. But for the agriculture, robotics playing different role to improve the productivity, which help of a tool and technology, and need of autonomous and time-saving technology, efficient farm management, replacing conventional technique of performance of same tasks with efficiency, and development of autonomous intelligent agriculture robots to prove repeatable precision, accuracy, and potential for the multitasking essentially. So these are the agriculture robotics required, and different advantages also that it can perform labor intensive and disaster. You just keep it in the field, it will start and working with that. And being a small site is prevent the compaction. Like if you think about the 50 HP tractor, that is about 2 ton, and it's going to the field of the moist condition. That will be also create the compaction situation. And this is a smallest, and we always try to come with a small one. And capable moving, staying precise, finding the disease, other things. These are the main advantage it can be do. And the agriculture robot can be equipped with the camera, sensor, detecting and guiding as per need. And these are the different functions where robots can be replaced from seed-based preparation to robotic irrigation also, micro spraying also, and this seeding. If it is what challenges? What are the challenges in agriculture? The physical structure suitable for agriculture environment, that is a challenge, because it is not the other robotics for the industrial. They are stationary type, most of them the stationary type, and they are working with the arm, and their plan are fixed. Their visibility is limited. But here in agriculture, their field terrain are not smooth as like that one. And the electronic structure to indicate various electronic devices. This is also complicated situation of the challenge. And compliance and variability of operational condition. If you different crop to crop and different zone to zone, you can find variability. So that is a challenge. And operational energy replacement. Like tractor, if you are working for the 4 hours or 6 hours, just you put the fuel and it go and run. But for the robotics, most of the robot, 1 or 2, if you robotics, Robotics and other companies are working on that. Most of the work on the energy with the battery operated. So their energy limitation. If you are working with a certain energy limit and you are going in the field, that is limit your operational parameters also. So how we can go with that one? That is also a challenge. And next is affordability and adaptability. This is another challenge because initial stage, whatever robots are coming, they are costly one. So these are the main challenges in agriculture. Now, in adoption, it is technological shift. You know that if any technology come for the public, it's little bit shift and people are hesitate. And it requires skill of individual. It cannot be, we can give the robot to any farmer with little bit knowledge of any just device, but it requires some skill. And another is fear of unemployment. This always happen with technological shift. This always happen that people understand that if robots come, where the unemployment situation. But now you think about during the time of peak season of requirement of the agriculture labor, that is not available many times. And early bird in investment and return. It is always problem. Who will come first to invest? If it is successful, many companies and many entrepreneurs comes and see that investment and their financial benefits. And next challenge is the cultivation variability. These are major challenges. If you see that animal finally lose their job during 40s when tractors come, and tractors automobile fusion with the farm. This is a tractor, and then after mechatronic merge with the farming. Now autonomous tractors. So these are the situations we are shifting, and we are going to the robotics also. And coming future, you can find everywhere robotics is the normal things. Now you see that industrial robot they are working, and now it can be agriculture robotics for the other purpose also. The current scenario in Indian prospects of the system, that the high demand supply requirement catering the need of growing population, shortage of labor, animate and mechanical power source use form, fail to optimize the operational cost, lack of precision machinery. Already Pradeep Rajan described this one. We have many machines, but where is the precision? No assessment of available nutrients in real time. Already you have seen in previous lecture. And let's focus on occupational health hazard of the farmer. High cost of cultivation, reduced profitability. This is a current scenario. Now, different. I'm going to just passing the slides. I'm not going to describe different one. Different scat robots, and this is another. In 2015, I have tried to find different robotics, but that time only few are. But now, if you just type on the Google, you can find many. But most of the robots, they are research level only. Only few robots they are claiming that they are going to commercialize one. So these are robots are the different. I just go through that one so that you can see the different robotics and system. And here another good company, Bosch and Bonio. This is a good company. Always, if you are going for the any robotic development, you always keep the things that a industry partner is capable to work with you. You have a good idea as a researcher, as an institution, as an academy, and some investment is required. Initial investment is required. If you combine this one, you can go and successfully you can develop that one. So this is another one model, and European Union global robot which are picking, but this is a small one. Just they are picking 1 or 2 and 5 and 10, but in future it will be very fast. So many companies are working with that one. There is no need of that thing. And the Horticulture, Denmark, another company, they have good. You can just use whatever you are working with that tractor operated machine. You can use that one, and you can just run that one. So this is another robot, and you can go. This Agri bot of second Australian. If you remember that 2015, I have one slide. Our Prime Minister visited in Australia and they have signed on this one. From that day, I have working on the robotics in agriculture. And here another robot. Okay. This is a new. Okay. This is a new. Now trial sample collection. This is smart. This is a new robot. I have a video, but I am saving the time. Just you go to the picture and just you know that different robotics for agriculture people are developing. Now Robo-AG and LCC, this is a startup and they are working. But most of the robots which develop, they are not commercialized yet. They are planning to commercialize that one. And this is another robot for cattle herd, developed for the cattle herd robot, which is just for the field and herd management system. And okay, this is a strawberry. I'm just going through that one, and my emphasis that what we are going to do in India, grape harvesting. All of this is an initial and research level. These are TED robots and working in the grapes. I will show some videos also of the robotics which are successful, and I would understand that they can be in future. Okay. This is another robot working in agriculture field for the weeding purpose. But all of these are just research platform. If you want to purchase, they will not sell because there is a patent and their ideas they have. They have copyright also. So they are selling. Even in European Union, they are developing and they are selling and they are trying to give as a demo in between them. They are not planning to take out from there so that people can copy. So this is also scenario because they have invested. They want return. Okay, now in the harvesting, I will just one operation I have to that how is harvesting. Just scanning, crop detection, grass, crop attachment, and detachment. I have a small video so that you can just see that how they are taking and catching and what are the path. So this is just information, and if you find that different cultivar. One detect rate is 92%, another cultivar is 42%. Here you can understand, if you change the cultivar, scenario will be changed. That means we require some additional knowledge and skill and AI also, so that we can go for the commercial purpose. Okay, this is one automation work is hand-free hectare. This is a very good concept in European Union that they have autonomous tractor and they have selected 1 hectare of land and they have mission that nobody enter in that field. Full complete mechanization. They are working with the autonomous tractor. They are seeding with that one. They are spraying with that one. And they are just harvesting after that without manual intervention. They are just taking out of field and they are harvesting and collecting the field. That is the first concept, and now they got a good fund for the hand-free farm, about 35 hectare land, and they are planning to work with it. Last year, I think from 16, 17, and 18, 3 years, they are working there, and 3 years they have harvested the crops and collecting. So this is a situation, and one good robots. I have already said that the energy challenge is there. If you use the battery system, then after some time or some limit is there. But if you use the diesel engine, there is no limit. Here, robotic company is giving very good concept of this one, that they have used the engine system, and both sides they have engines, and they have a hydraulic system. The whole power of ground wheel they have run with the hydraulic system. So this is autonomous one, and they are working all operations with a single robotics, and they are planning to sell also. But in near future you can find it also. They are in fine tuning situation, and they are staying waiting. Another thing, they are working there, and most of the work which you can work with the tractor, you can also work with that one. This is a GPS module connected one, and there is a good planning and good work. So this is another, I think from the WhatsApp university you can find many science eco-robotics. This is the smallest one, and this is a micro spraying system, and they have also putting its commercialization system, and this is a solar powered one, and so that very less weight, and you can use this robot with 90% saving of herbicides. And this, I think already most of you have seen this one, robotics. They are just detecting and spraying the vision-based system. And the one popular company in the Blue River technology, if you heard that one, they have worked on the weeding system, vision-based. See and history on that. That is another company, and now that we acquired by the John Deere, and this is a system. And the company is Neo. This is also Dino is a good company, and this is also going to commercialize. They are using same as per the tractor, just you keep the tool here and they work. And their weight is about 800 kg, and it's cover 4 hectares per day. So this is a situation, And now I come to the Indian initiative. Okay, now this is a 14/11/14. November 14, our PM visited in Australia, and they have signed on this robotics, agriculture robotics, and from where we have started that working in agriculture robotics in India. Our first plan, and we have submitted one proposal in ICR. The proposal is very simple. That if you take a concept of the printing of A4 size paper, whatever you give the command of printing page by page, and where you give the A or Z whatever writing, they will give the input of ink at the same location and same place. Why we cannot possible that we can go for the any robotic or any machinery which can be used in the field, exact precision of that one. So we have put that one, and if you consider that different plots are the paper, and these printer or you can robotics where you can optimize. So we have developed that one, the development of robotic precision planter, and we have concepted this one and design implementation like structure, hardware, sensor. Here I can acknowledge our partner IIT Kharagpur and IIT Kanpur. They are partners in that. As per concept, we have worked on that. They are working on the electronic implementation, and IIT Kanpur is for the mechanical strength and other things. We have planned that one. Initially, we have planned that which type robot we can go for that. There is differential speed of the robotics wheel for the steering purpose. Can we do that one? And we have developed that steering of individual wheels. So here, if you see that one, the first model we have fabricated with our own 3D printers, and we have developed that one. And we have run a small run, and we have tried to find that how it's working. We have just tested this for the steering and other things, and then after we have compared with its operation, like the whole system is running and how it's running, and it's going for the different page after that. So this is a basic concept of the control moment, and then after we have developed our own. And these by the Kharagpur, they have sensors so that they can detect the obstacle and they plan their. So this is a basic concept of this one, and we have chosen out of we have selected that so we can go up with the first one. And we have worked with we have just fabricated in our old workshop, and we have fabricated. Here you can see that stepper motor we have used, because this is an open loop system that if you give the command of one pulse, that is rotate 1.8 degrees. This is a pulse, and there is a gear, the direction of the planetary gear, and this is with this one. So this is a basic one unit of the traction, and we have designed a cost and coordinate, and initially we have cost is also parameters that we have tried to find the linear rail in the market. They are so costly, but we have tried our own, and we have developed. Initially we have make with the 3D printed one, but after that we have make with the aluminum body. So this is our motor, and this is a NEMA 34 motor with gear ratio of 5.1 and 24 volt voltage to 48 voltage. This is a driver. I think this is a for the steering we have tried to this one, but we could not succeed, and we have used different one because there is a 150 kg is not enough, and their gear mechanism is also not a good enough to hold the capacity of steering top. So this is we have made a hollow and other things so that weight will be reduced, and we have simply used the full and a tire which is available in the market. What we have done, especially in there, that we have used a pure lead-tin battery. Their life is about 10 years, and good up to 90% discharge. They doesn't lose their voltage. So this also we have visited in IIT Chennai. Their Alok Mukherjee from DRDO, we have discussed with them, and they have suggested that you go for the pure lead 10 battery, because this battery is used in the aeroplanes as well. They are DRDO using in the Dhruv. One robot is there for the defense purpose they are using. So I have also used this with this one. And another thing is my robot is now ready. This is a robot, and this is the concept of that. It is planting, seed planting robot, and this is just we have put the developer that they are planted at per side. I saw that video. This is a control system where you have used the as a processor of Raspberry Pi and the microcontroller as a Mega. Due to Mega and Arduino, now people can very easy to control anything. And this is a Gaussian coordinate. Here I have purchased this is a Z direction because this school system is required and little bit force is required. So we have purchased this. This is not a costly one, about 70,000 rupees of 50 centimeter stroke. But all others like Y and X, we have developed our own. So this is the total weight of my robot is 460 kg, and dimension is about 1.55 to 1.8, and height is 1.25. And distance is initially we have started with the distance curve geometry. Thin net 40 seconds after one block, you can say that. And after programming, we have reached up to 2 minutes 50 seconds modifying, and it can run about 4 hours. And we have tested. Initially, this is the first we started, then we have put that one, and we have also developed an app based. Just you command with the mobile, just give command, it start working. But this is the initial stage of any development. So this is my robotics. We are just checking that its accuracy of the placement of the seed, and it is about 2 minutes. So I little bit forward it so that can save some time. Okay. After completing the whole job, they will come to the home. In that, one of my students they have asked that how is the size, means repeatability and accuracy is how much. So we have just simulated in the lab, as well as we have visited in the field also. So this is just I'm forwarding this one so that we can save the time, and more interaction will be important for this one. And just it is coming for the home. This is a simplest one because it is an open loop system. So as per the command they are running, and we have just tested in the field then how it's running in that one. So this is a system, and this is my student and my other faculty members who are just watching this one. In the robot is some requirement trolley and other things so that we can take from the lab to the field. So there's one carrier is required, and this is autonomous. Just if you are giving a command like your printer, if you just give the print command, they will do all things. You are not going to change the other things. That is same thing. Just you make a program, and you can give from your laptop. Wirelessly, they will communicate with the Raspberry Pi to the controller, and they will work there. And so it's some dynamic control system, process automation system. We are trying to equip in that. We have also proposed that one. Here, I think he is going to show the steering capability. Now it's steering. We have changed this one, steering. So this is a system, and which we have developed. And one of my students has planned this field to run this one. I think this is video, and this is a command based, and this is everywhere. This is NEMA 34. We have changed for steering. NEMA 34 is here, and NEMA 34 is here in steering. And NEMA 23 is for the pushing this one. And just I'm forwarding this one so that you can, after completing one block, they move to another block. As per the command, they are going to that one. This is as per whatever you give the programmable, that plant to plant and row to spacing, they will work with that one. So that's you give the command and they will do it. Here we can save the time, like keeping the two motion at a same time, so that we can uh, reduce the time. Okay. Okay. That's we have some evaluated its performance on the different speed and other things and different curve geometry, and we compare with the manually, but for the accuracy purpose, this is robotics is good, but for the manually, it's required labor and other things, and just give the command of the student measuring the curve. And this is a deviation. We have tried to find that what deviation in the field as well as the lab. If you give the command, how much it deviated. If you see that it is not a mm, sometimes it is 0.1 mm or 0.5 mm. That is good enough for the agriculture purpose, especially. And this is the absolute spacing. How differ with that? It must be exactly same required. But if you increasing the speed little bit, this is a 1 mm or 0.5 mm only. That is not a more than that one. This is planted with the robotics, and this is a graph and our professor. Another work which is going in the India, one company is 𝐀𝐠𝐫𝐢𝐇𝐎 is a Bangalore and Manohar Sundaram is a good friend to mine, and he is also developing cotton harvesting robots, and that is a good one. And they have can pick 250 kg per day, and this is a image based one, and they have developed different yantra, mark, and vistara, different robotics, and they have also a smart vehicle they have tried to develop, and still it is in development, so that 12 arm can be. Here I have one video of this caption. This is just flashing on the cotton, and they detect their distance from the arm and location in 3D motion. And if you see this one, it is you see they are flashing, and once they flash, they target the different ball, and they are taking that one. So this is a new initiative in Indian prospect, you can say that, and they are working with that one. And recently, I think in Marathwada Agriculture University, they are planning to purchase robots, and they have contacted me also that where they can purchase, and they have called a meeting of the different robotics development man. But nowadays you can understand that different companies which are working in the robotics for the industrial, they are also coming for the agriculture purpose. But cost is the matter. Due to cost and their requirement are market. Initially, this is not a nowadays a market. Even research institution, academician, or some advanced farmer can purchase that one, because that is the costly one. And other company have concept. This is a Bangalore based. This is also robotics and computer vision based and precision displaying system they are using. This is a AI powered with display solution. So these are the basic things which are working, and different other companies in India also working in this aspect. But we are planning to in future we can cultivate from home will be reality in the future, and we hope all of you listening and interested in this area robotics and advanced agriculture trend, and you are maybe asset for us in future to make this dream fulfill, cultivate from home, and we can do that. Nowadays people are working from home. Can we work from the cultivate from our field? So this is all about okay, can I
Sure.
okay, this is all about if any question, I'm happy to see your interaction.
Okay, thank you, Dr. Kushwaha sir. Very nicely enlightened our knowledge toward the development of robotics in agriculture, or even in the in India. And you have shown a very good model developed by you, that and giving us the shows us the live demonstrations how the this robotic planters can work and can help us for precision agriculture. And also there is a various robots has been developed that is used for the cotton harvesting, and really it is helps our farmers so for the cotton harvesting. So now I would like to open the platform for the participants. Those who have any questions, query regarding these presentations, they may proceed. Pranay Sarkar, you have a question, so you can ask. Pranay Sarkar, are you there? Okay. Praveen?
Yes, sir. My question is general, like currently a lot of people is using robots in delivering the food in a big restaurant with having some mapping on that coupons. So same robotics like which we use in the field, they require some data of the field as well as the plant as well as the picture of the plant and software. So this type of things which we inputs in the robot software. So what you feel the cost of that robot increase because the cultivation of the plant will differ. Multi-cropping system, if there is a multi-cropping system in that agriculture field, so what your views on that, sir?
Good idea, Praveen. I think you have catch very well that can we work for the, like if you know that cultivate plant-based, like if a robot which visit the field, they are planting, they know the mapping of the different seeds that where they have planted and what is the location. In next visit of the robots, they can understand how it's go, what deficiencies are there. They can put accordingly. They have just spray like out of 100, any plant little bit deficiency of anything like nitrogen or phosphorus, due to AI and vision based, they understand, and they just inject a small quantity of the material, that is chemical, so that they can know that from growth, from planting to growth up to harvesting, they can understand each and every plant with ID. They give the temporary idea of each one, and they can, this is a possible one. But initial nowadays, people are working in the robotics in worldwide. They are especially nowadays weeding and planting and vision-based weed detection and the harvesting. These are the main ideas. But whatever you are saying, people are thinking about this. Can we go for the field with the individual plant husbandry, not a plant husbandry? Individual plant we can monitor and we can detect and we can nourish with each plant. So this is a system is going. Your idea and your question is very right. Yes, we can go, but it requires time. And in future, I think your idea may be applied with many people. Now, about 100 people here, and they can listen, and anybody can take this idea and go for the next development. Thank you, Karanji.
Thank you. Thanks, sir.
Questions from participants?
I have a query from TNAU.
Yes.
As we mentioned, I am Subramanian, Director of Research from TNAU. Kaushik, your presentation was excellent. And is there any robot available for scale-up?
Yes, Subramanian sir, thank you. And you have given your time for this presentation as well as previous one, and you are very interested and you are nicely. Even if you know that your dean has approved this project, my project, during external project. And that is very nice. And I think for the robotics, Maharashtra Agriculture University, they are trying to purchase one robot because they have kept money for that one, and they have the project. And they have contacted me, and I said that robots are there, like robotics. They have also 3-4 center in Denmark and nearby countries they have, but they will not sell in India or Asian countries because their copyright and other things violation may occur. So they are afraid with that. But no problem. Many other industry, robotic companies will have industrial-based robotics. They are coming very fast. I think 15 or 20 days before, they have one meeting. There are many companies. They have many plans. I think they will purchase this year or next year. They can purchase, and that will be starting point of robotics in application, or they can marketing. And near future, within 5 years, I am changing very drastically that robotics development in worldwide, even in India. People are working very well, and every institute, academician, they are working. So I am very happy that we can dream of cultivate from home in near future.
You know, the Director General of ICR has.
Yes. Yes, he has approved my project.
They frequently ask me to put a joint proposal, and I have a nice idea now. We work together. TNAU and IRI can work together on
yes,
this.
Yes, I am always ready.
Okay.
Sir, if you know that we have proposed one NSF project. That time we are searching for the partners. In that, Parmani and CIA Bhopal and Anand Agriculture City and myself and IIT Delhi. We 5 made one project and we have submitted because our limitation IRI has limited number allotted for the submission. So I have given to the Parmani.
Yeah, I am there in NSF as one of the committee. I am the chairman.
Thank you.
I have to look at it.
We can make it possible.
It is in the screening process now. And the next level, you can also include TNAU because we are eager.
Okay, you just including that so that we can make a big team.
Yeah, sure. Okay. Thank you very much. Good opportunity. Thanks to the organizer for arranging a nice presentation. Thank you very much.
Thank you, sir.
Thank you, sir. Any other questions from the participant? Okay. So I think there is no other questions. So I will again thank Kushwaha sir for a nice presentation and very informative one. Now I will request Dr. Om Prakash, one of our faculty member and the secretary of this organizing committee, to put or convey his vote of thanks.
Okay, thank you, Ashish sir. So here in this webinars, we have seen the 3 continuous presentations on the precision agriculture, and we have seen the role of the robotics, role of the artificial intelligence, and automations. How we can improve the agriculture productivity, how we can provide these technology from the lab to the field. And we have seen the live demonstrations of one of the robot that is developed in the IARI under the guidance of the Dr. Kushwaha sir. So all the 3 speakers has given us valuable informations, inputs, and provided us where is the knowledge gap and how we can rectify this gap to improve and move toward the precision agriculture. So, and Dr. Pradeep Rajan sir also have enlightened us regarding the whatever the different agri machinery or the equipments needed for increasing the farm mechanizations and productivity for in the land. So now I would like to thank all the 3 speakers, Dr. Rajan sir from the IIT Kharagpur, Dr. Pradeep Rajan sir from CMERI CSIR, and Dr. H.L. Kushwaha sir from IRI for their giving us the time and providing us or enlightening us the knowledge in the precision agriculture and the automations and artificial intelligence inputs. And now I also extend my thanks toward the Vice Chancellor of this university, Uttar Banga Krishi Vishwavidyalaya, for providing us the facilities to organize this webinar and giving us the time so that we can complete these webinars within the time frame. And also would like to thank the principal investigator of the NIAP project, who basically giving us the financial support for organizing this webinar, and other officials of this university like Dean Faculty of Horticulture, Dean Postgraduate Studies, Dean Agriculture, Dean Faculty of Horticulture, Director of Research, Director of Extension Educations, and the Dean Students Welfare for providing us the supports for organizing this webinar. Now, NIAP project staff also actually involves for providing the technical supports for organizing these online platforms under the Zooms